What if I told you that the ground beneath your feet right now was once scattered across the entire galaxy as invisible dust, and that this dust somehow gathered itself into a molten ball of fire that took 4.5 billion years to become the perfect cradle for life? This impossible journey actually happened, and tonight, as you drift towards sleep, you'll discover how the most violent cosmic catastrophe in our solar systems, history, became the gentle home that now rocks you to sleep. In the next 3 hours, you'll witness the birth of our planet through the eyes of science and wonder, feeling the cosmic forces that shaped every grain of sand, every drop of water, and every breath of air around you. Scientists kept some of these discoveries hidden in classified research for decades, until breakthrough technologies finally revealed the truth about Earth's mysterious beginning. NASA's recent deep space observations have uncovered evidence that Earth's formation was far more dramatic and beautiful than we ever imagined. Before we begin this cosmic lullaby, take a moment to like this video if you're ready for this journey. Subscribe for more peaceful cosmic stories, and comment below with your country and the time you're listening. Knowing you're out there, somewhere under the same ancient starlight, makes this shared journey even more magical. Now, settle in comfortably, close your eyes if you wish, and let's travel back to the very beginning of everything you've ever known. Imagine floating in absolute darkness, surrounded by nothing but cold, silent space. This is where our story begins, not 4.5 billion years ago, but even further back, in the heart of a dying star that would never know the world it was about to create. Picture a massive star, perhaps 50 times larger than our sun, burning through its nuclear fuel in the cosmic equivalent of a heartbeat. This ancient giant had been shining for millions of years before our solar system was even a whisper in the universe's imagination. Deep within its core, temperatures reached hundreds of millions of degrees, forging the very elements that would one day become the calcium in your bones, the iron in your blood, and the oxygen you breathe as you listen to these words. But here's where the mystery begins. This star was destined to die in the most spectacular way possible, and its death would birth our entire solar system. The question that has puzzled scientists for generations is this: how did the violent explosion of a dying star create something as perfect and life-giving as Earth? As you rest there in the darkness of space, feel the gentle pull of gravity beginning to work its ancient magic. The star's outer layers are starting to cool, and somewhere in the distance, nuclear fusion is slowing down. The star is running out of fuel, like a fire slowly consuming its last pieces of wood. But unlike a campfire that simply fades away, this stellar giant is about to give the universe a gift beyond imagination. The core begins to collapse under its own immense weight. In less than a second, matter as dense as an atomic nucleus compresses into a sphere barely 12 miles across. The temperature soars to billions of degrees. And then, in a flash of light visible across galaxies, the star explodes in what astronomers call a supernova. But this isn't just destruction. This is cosmic creation at its most magnificent. The explosion sends shockwaves rippling through space at thousands of miles per second, carrying with it all the heavy elements forged in the star's core: gold, silver, carbon, nitrogen, silicon, and iron, all the building blocks of planets and life, scatter into the darkness like seeds from a cosmic dandelion. Now picture these elements, still glowing hot from their stellar forge, beginning to cool in the vast emptiness of space. They form tiny grains of cosmic dust, each one no larger than particles of smoke, drifting on invisible currents of solar wind and magnetic fields. This dust will wander through space for millions of years, carried by forces too subtle to see, too patient to hurry. This is the mystery we'll solve together tonight. How did this cosmic dust, scattered across light years of empty space, somehow gather itself into the solid ground beneath you? The answer lies in one of the universe's most beautiful and gentle forces, working so slowly and quietly that you could watch for a human lifetime and never see it move. As we drift deeper into this story, feel yourself becoming one with these ancient particles, floating peacefully through the cosmic dark, carrying within you the memory of stellar fire and the promise of a world yet to be born. Something extraordinary is happening in the darkness around you. Those tiny grains of stardust we left, drifting through space, are no longer alone. The supernova's shockwave has awakened something that was already there, waiting in the cold depths of space. A vast molecular cloud, stretching across dozens of light years, filled with hydrogen and helium left over from the universe's earliest days. This cloud has been floating here for millions of years, so thin that it contains less matter than the best vacuum we can create on Earth. If you could hold a cubic mile of this cloud in your hands, it would weigh less than a paperclip. And yet, within this seemingly empty space, gravity is beginning to weave its patient spell. Here's the first revelation that changes everything. Gravity never sleeps. Even when matter is spread so thin that it seems like nothingness, every single particle is still whispering to every other particle across the vastness of space. These whispers are incredibly faint, but they never stop, never fade, never give up their gentle insistence that everything belongs together. The stardust from our exploded star begins to mix with the hydrogen cloud, and something beautiful starts to happen. Imagine you're watching this process unfold, but time is accelerated, so you can see changes that normally take thousands of years. The cloud begins to ripple and swirl, like cream stirring slowly into coffee. But here's where the conflict begins. Two opposing forces are now at war in this cosmic nursery. Gravity wants to pull everything together, to collapse the cloud into a single point. But the cloud is spinning, and this rotation creates centrifugal force, trying to fling everything apart. It's like a cosmic tug-of-war, played out across distances so vast that light takes years to cross from one side to the other. For millions of years, these forces remain in balance. The cloud spins lazily through space, neither collapsing nor flying apart, like a sleeping giant breathing slowly in the cosmic dark. But the supernova has tipped the scales. The shockwave has compressed parts of the cloud, creating regions where gravity's whisper becomes a little louder, a little more insistent. Picture yourself floating within one of these compressed regions. Around you, the density of matter has increased ever so slightly. Instead of encountering one hydrogen atom every few cubic inches, you might find 2 or 3. It seems like nothing, but in the patient mathematics of gravity, this tiny change begins a cascade that will reshape the entire region of space. The denser regions begin to attract more matter from their surroundings. As more matter accumulates, gravity grows stronger. As gravity grows stronger, it pulls in even more matter. This is what scientists call gravitational collapse, and it's happening so slowly that if you were human-sized and floating here, you would never perceive the motion. But if you expand your awareness to cosmic scales, you can feel the cloud beginning to gather itself inward, like a slow-motion whirlpool in an ocean of stars. At the center of this growing whirlpool, something remarkable is taking shape. Matter is beginning to concentrate into what will eventually become our sun. But here's what makes this process so mysterious and beautiful. As the cloud collapses inward, it also flattens outward, forming a vast spinning disk of gas and dust. This disk stretches farther than the orbit of Pluto, and within its swirling patterns lie the seeds of all the planets, including the precious world that will one day cradle life. Feel yourself settling into this disk now, carried along by currents of dust and gas that move with the stately grace of cosmic ballet. You're part of something that has never existed before and will never exist again in exactly this way. This is the solar nebula, the cosmic womb from which Earth will be born. As this chapter closes, notice how the conflict between gravity and rotation has created something entirely new, a stable spinning disk where planets can form. The war between opposing forces has become a dance, and in this dance, the stage is being set for Earth's grand entrance. You're now floating within the spinning disk of the early solar system, and something unprecedented is about to happen. The gentle dance we've been watching is about to become much more dramatic, but in ways that will surprise you. Within this vast disk of dust and gas, temperatures vary dramatically depending on how close you are to the forming sun. Near the center, where our star is beginning to ignite its nuclear furnace, temperatures soar to thousands of degrees. Here, only the most heat-resistant materials can survive. Metals like iron and nickel, and rocky compounds like silicates. Further out, where the disk is cooler, water can freeze into ice, and gases can condense into solid form. But here's where our story takes an unexpected turn. Scientists used to believe that planets formed through a slow, gradual process of dust particles sticking together like cosmic snowballs. But recent discoveries have revealed something far more dynamic and surprising. The birth of planets was actually a series of cosmic catastrophes, each more dramatic than the last. Picture yourself shrinking down to the size of a grain of sand, floating within this disk. Around you, billions of other particles drift in complex orbital patterns, each following the invisible pull of gravity and the subtle push of solar radiation. At first, when particles collide, they do indeed stick together through static electricity and weak molecular forces, just like dust bunnies forming under your bed. These tiny aggregations grow slowly at first. Dust grain by dust grain, they accumulate into pebbles the size of marbles, then rocks the size of boulders. This process takes millions of years, and it seems peaceful enough. But as these objects grow larger, their gravitational pull increases, and something remarkable begins to happen. The larger objects start to dominate their orbital neighborhoods, sweeping up smaller particles like cosmic vacuum cleaners. But here's the crucial pattern break. Once these growing worlds reach a certain size, about the mass of our moon, they begin to interact with the gas disk in ways that completely change the rules of the game. The disk of gas and dust is not smooth or uniform. It's filled with turbulent currents, pressure waves, and density variations that create cosmic weather patterns unlike anything we see on Earth today. These massive protoplanets begin to migrate through the disk, their gravity carving spiral waves in the surrounding gas, causing some worlds to spiral inward toward the sun, and others to drift outward into the cold depths of space. Imagine the early solar system as a cosmic pinball machine, with planetary embryos ricocheting off each other's gravitational influence, sometimes combining in spectacular collisions, sometimes shattering into pieces that would reform into new worlds. The stakes are escalating because each collision, each merger, each near miss is determining the final architecture of our solar system. This is where Earth's story becomes truly dramatic. In a region of space about the same distance from the Sun as Earth orbits today, dozens of planetary embryos are engaged in a gravitational ballet that will last for hundreds of millions of years. These protoplanets range in size from our moon to Mars, and they're all competing for the same orbital real estate. The tension builds as these worlds grow larger and their gravitational influences become stronger. Close encounters become more frequent and more violent. Some embryos are ejected entirely from the solar system, flung into interstellar space by gravitational slingshot effects. Others spiral inward and are consumed by the growing sun. But a few lucky survivors will find stable orbits and continue to grow. One of these survivors, a world about the size of Mars, will eventually experience the most important collision in Earth's history. But that cosmic catastrophe is still millions of years away. For now, feel yourself riding along with one of these growing worlds as it sweeps through its orbital path, accumulating material and gravitational influence with each passing millennium. The process is both violent and creative, destructive and generative. Each collision that shatters a world also provides raw material for new worlds to form. Each gravitational ejection that removes a competitor also creates more space and resources for the survivors to grow. The early solar system is sculpting itself through chaos, finding stability through catastrophe. As this chapter ends, sense the mounting tension in this cosmic drama. The casual, gentle accumulation of dust grains is giving way to something far more dynamic and unpredictable. The stakes have never been higher, because the next phase of Earth's formation will determine not just what kind of world it becomes, but whether it survives at all. We've reached a crucial moment in Earth's formation, and I want to acknowledge something beautiful about this shared journey we're on together. Whether you're listening to this in New York at midnight, in Tokyo at dawn, in London during a quiet evening, or anywhere else on our planet, you're experiencing the same story that every atom in your body has lived through. The calcium in your bones, the iron in your blood, the oxygen in your lungs, all of these elements have been on this 4-and-a-half-billion-year journey, from stellar death to planetary birth, to the miracle of consciousness that allows you to understand this story. You are made of the same materials we've been following through space and time. Now, let's witness one of the most intense periods in Earth's history, the Late Heavy Bombardment, a cosmic storm that lasted for hundreds of millions of years and nearly prevented life from ever emerging on our world. Picture Earth as it existed about 4 billion years ago. It's already recognizable as a planet, having grown to nearly its current size through the accumulation and collision processes we've been following. But this early Earth would be utterly alien to your eyes. The sky glows a deep orange red from the heat of constant volcanic eruptions. The surface is covered in molten rock that flows like rivers of liquid fire. The atmosphere is a toxic mixture of methane, ammonia, and carbon dioxide, with no oxygen to speak of. And most dramatically, the sky is filled with streaks of light as asteroids, comets, and planetary debris rain down from space in a bombardment so intense that the entire surface remains molten. This bombardment isn't random. It's the final chapter in the gravitational cleanup of our solar system. The massive outer planets, Jupiter and Saturn, have settled into their final orbits, and their gravitational influence is stirring up the asteroid belt and the distant realms of icy comets. Like cosmic shepherds, these giant worlds are flinging debris inward toward the sun, and much of this debris is intersecting Earth's orbit. But here's what makes this period so crucial to our story. This bombardment, which seems so destructive, is actually delivering the ingredients that will make life possible on Earth. Many of the impacting objects are water-rich comets from the outer solar system, carrying with them the oceans that will one day cradle the first living cells. Others are carbon-rich asteroids, bringing the organic compounds that will become the building blocks of DNA and proteins. Imagine standing on the surface of this early Earth, protected by some cosmic force that allows you to witness this spectacle safely. The ground beneath your feet is solid rock, but just barely. The heat from the bombardment keeps the surface temperature at nearly 2,000 degrees Fahrenheit. Above you, the sky is crossed constantly by brilliant meteors, some as small as pebbles, others as large as mountains. When one of the larger impactors hits, the explosion is beyond anything in human experience. A single asteroid just 10 miles across releases energy equivalent to millions of hydrogen bombs. The impact creates a crater hundreds of miles wide and throws molten rock high into the atmosphere. For days afterward, the sky rains liquid stone as the debris falls back to Earth. But gradually, almost imperceptibly, the bombardment begins to lessen. The solar system is running out of debris to throw at Earth. The gravitational cleanup is nearing completion. And as the impacts become less frequent, something miraculous begins to happen. Earth starts to cool. The cooling process is gradual and uneven. First, the surface temperature drops below the melting point of rock. A solid crust begins to form, like ice forming on a pond. But instead of water freezing, it's liquid rock solidifying into the first continents. These early land masses are nothing like the stable continents we know today. They're constantly being reshaped by volcanic activity and the occasional large impact, but they represent the first solid ground in Earth's history. As the surface continues to cool, the water vapor in the atmosphere begins to condense. For thousands of years, it rains constantly, as the water delivered by comets and asteroids finally comes to rest on the cooling surface. The first oceans form in the lowest regions, fed by this endless rain and by volcanic outgassing from Earth's interior. Feel yourself witnessing this transformation from a world of fire to a world of water and rock. The change is so gradual that you would need the patience of geological time to perceive it, but it's happening nonetheless. The bombardment that seemed so destructive has delivered exactly the materials needed for habitability. Water for oceans, carbon for organic chemistry, and a cleared orbital neighborhood that will allow stable conditions to persist for billions of years. This is the deep lesson of Earth's formation. Creation and destruction are not opposites, but partners in a cosmic dance. The same forces that could have sterilized our planet instead prepared it for the emergence of life. The bombardment that could have shattered Earth instead delivered the gifts that would make it a cradle for consciousness. As we transition to the next phase of our story, notice how the violence of cosmic formation has given way to the more subtle processes that will shape Earth's future. The foundation has been laid through fire and impact. Now comes the longer, gentler work of creating a world where life can not only survive, but flourish. As we continue our journey through deep time, something extraordinary connects back to our opening mystery. Remember how we began with the death of an ancient star, whose explosions scattered the elements of life across space? Now, billions of years later, those same elements are about to participate in the most important chemical revolution in Earth's history, the Great Oxygenation Event. You're now floating above an Earth that's about 2.5 billion years old. The surface has cooled and stabilized, continents have formed, and vast oceans stretch from horizon to horizon. But if you could take a breath of this ancient atmosphere, it would kill you instantly. There's almost no oxygen, and the air is filled with methane, hydrogen sulfide, and other gases that would be toxic to any complex life as we know it. Yet something remarkable is happening in the shallow seas below. The first forms of life on Earth, tiny single-celled organisms called cyanobacteria, have learned to harness the energy of sunlight in a way that will transform the entire planet. They've developed the ability to perform photosynthesis, using solar energy to convert carbon dioxide and water into sugar and oxygen. This might seem like a simple biochemical process, but it connects directly to our cosmic story in a profound way. The iron atoms that these bacteria are using in their photosynthetic machinery were forged in the heart of that ancient star we met at the beginning of our journey. The hydrogen in the water they're splitting came from the very first moments after the Big Bang, and the carbon dioxide they're converting was exhaled by countless volcanoes as Earth's crust formed and reformed over billions of years. Picture yourself shrinking down to microscopic size and floating among these ancient bacteria in a shallow prehistoric sea. Each one is smaller than the thickness of a human hair, yet they're engaged in chemical processes of staggering complexity. Inside their tiny cells, molecular machines built from stellar atoms are capturing photons that have traveled 93 million miles from the sun, and using that energy to break apart water molecules and reassemble them into food and oxygen. At first, the oxygen these bacteria produce doesn't accumulate in the atmosphere. Earth's early oceans are filled with dissolved iron, and oxygen is highly reactive with iron. As fast as the bacteria can produce oxygen, it combines with iron to form rust, which settles to the ocean floor in layers that we can still see today in some of the world's oldest rock formations. But the bacteria are persistent. For hundreds of millions of years, they continue their work generation after generation, each one capturing a tiny bit of solar energy and releasing a few molecules of oxygen. The process is so gradual that if you were watching from space, you would see no change from year to year, or even from century to century. However, Chemistry has its own patience. After hundreds of millions of years of constant oxygen production, something dramatic happens. The dissolved iron in the oceans is finally exhausted. There's no more iron left to rust. And suddenly, the oxygen produced by photosynthesis has nowhere to go except into the atmosphere itself. This is when Earth experiences its first global environmental crisis. Oxygen, a gas that we think of as essential for life, is actually highly toxic to the anaerobic organisms that have dominated Earth for its first 2 billion years. As oxygen levels in the atmosphere begin to rise, it's like a slow-motion poison gas attack that affects every living thing on the planet. Most of Earth's original life forms cannot survive in an oxygen-rich environment. They retreat to deep ocean vents, underground caverns, and other places where oxygen can't reach. It's one of the greatest mass extinctions in Earth's history, and it's caused not by an asteroid impact or volcanic eruption, but by the waste product of photosynthesis. Yet this apparent catastrophe sets the stage for something extraordinary. Oxygen is not just toxic, it's also incredibly energy-rich. Organisms that can learn to use oxygen for respiration can generate far more energy from their food than those that rely on other chemical processes. It's like the difference between a campfire and a nuclear reactor in terms of energy output per unit of fuel. Some organisms do learn to not just tolerate oxygen, but to thrive in its presence. These are the ancestors of all complex life on Earth, including you. Every breath you take connects you to this ancient revolution. The oxygen molecules entering your lungs right now were produced by the descendants of those pioneering cyanobacteria, using the same basic photosynthetic process that transformed Earth's atmosphere 2.5 billion years ago. As you breathe slowly and deeply, contemplating this connection, feel the oxygen flowing into your bloodstream, where it combines with iron in your red blood cells, just as it combined with iron in the ancient oceans. But instead of forming rust that settles to the seafloor, it's carried to every cell in your body, where it powers the molecular furnaces that keep you alive and aware and able to contemplate this cosmic story. The Great Oxygenation Event reminds us that Earth's formation didn't end when the planet reached its current size. The processes that shaped our world continued for billions of years, with life itself becoming one of the most powerful geological forces. The bacteria that learned to split water molecules using stellar energy didn't just create oxygen. They created the conditions that would eventually allow consciousness to emerge from matter, enabling the universe to know itself through minds like yours. We're about to explore one of the most impossible and beautiful phenomena in Earth's story: the magnetic field that surrounds our planet like an invisible shield, protecting all life from the harsh radiation of space. What makes this phenomenon seemingly impossible is that Earth's magnetic field is generated by a process so complex and dynamic that scientists are still unraveling its mysteries today. Float with me now deep beneath Earth's surface, down through the solid crust, through the hot mantle of flowing rock, all the way to Earth's core, nearly 4,000 miles below your feet. Here, in conditions more extreme than the surface of the sun, liquid iron flows in patterns so intricate and powerful that they generate a magnetic field extending far into space. The story of Earth's magnetic field begins with the very formation processes we've been following. When Earth was still growing through the accretion of cosmic debris, the heaviest elements, particularly iron and nickel, sank toward the center due to gravity. This process, called differentiation, created Earth's layered structure: a thin rocky crust, a thick mantle of hot rock, and a core divided into two parts: a solid inner sphere of iron and nickel, and a liquid outer core of the same materials. But here's where the impossible part begins. This liquid iron core is not sitting still. It's in constant motion, flowing in complex currents driven by Earth's rotation, heat from radioactive decay, and the cooling of the planet's interior. Imagine rivers of molten iron, each one carrying as much metal as all the iron ore ever mined by humanity. flowing in spiral patterns around Earth's center at speeds of several miles per year. These flowing currents of liquid metal create electric currents, and electric currents always generate magnetic fields. But the magnetic field created by Earth's core is not static or simple. It's dynamic, constantly changing, sometimes even reversing its polarity completely, so that magnetic north becomes magnetic south and vice versa. To understand how remarkable this is, picture yourself floating in space above Earth's North Pole, able to see magnetic field lines the way you might see the aurora. The field lines emerge from Earth's core, curve out into space in elegant arcs, and reconnect at the south magnetic pole. This magnetic cocoon extends tens of thousands of miles into space, far beyond the orbit of any spacecraft, creating what scientists call the magnetosphere. This magnetosphere is what makes Earth habitable. Our sun doesn't just emit light and heat. It also produces a constant stream of charged particles called the solar wind. These particles travel at over 1 million miles per hour and carry enough energy to strip away planetary atmospheres. Mars, which lacks a strong magnetic field, has gradually lost most of its atmosphere to the solar wind over billions of years. But Earth's magnetic field acts like a cosmic deflector shield. When the solar wind encounters the magnetosphere, most of it is diverted around Earth, like water flowing around a stone in a stream. The charged particles that do penetrate the magnetic field are guided toward the polar regions, where they interact with atoms in our atmosphere to create the aurora borealis and aurora australis, the northern and southern lights. Here's what makes this phenomenon truly impossible by the standards of human engineering. Earth's magnetic field generator has been running continuously for billions of years without any external maintenance or fuel source other than the gradual cooling of the planet's interior. It's a self-sustaining dynamo of unimaginable power and complexity. The liquid iron in Earth's outer core is not just flowing randomly. The currents form complex three-dimensional patterns influenced by the Coriolis effect of Earth's rotation, convection currents driven by temperature differences, and the interaction with the solid inner core. These patterns change constantly, sometimes gradually over thousands of years, sometimes abruptly over decades or centuries. Scientists have discovered that Earth's magnetic field has reversed its polarity many times throughout geological history. During these reversals, which can take anywhere from a few thousand to a few 100,000 years to complete, the magnetic field weakens dramatically and sometimes breaks up into multiple poles before reorganizing into a new configuration. We're currently living through such a period of magnetic instability. Earth's magnetic North Pole has been moving across the Canadian Arctic toward Siberia at an accelerating pace, and the overall strength of the magnetic field has been decreasing. Some scientists believe we may be approaching another magnetic reversal, though predicting the timing of such events remains beyond our current understanding. But even during magnetic reversals, life on Earth has survived and thrived. The atmosphere provides additional protection from cosmic radiation, and life is proving remarkably resilient to changes in the magnetic environment. The very fact that you exist is proof that Earth's magnetic shield has successfully protected the chemistry of life for billions of years. As you rest now, feeling the subtle influence of Earth's magnetic field on the iron in your blood, on the electrical activity in your nervous system, remember that you are living within a protective sphere generated by rivers of molten metal flowing deep beneath your feet. This invisible shield, powered by the same gravitational and thermal forces that formed Earth itself, continues its patient work of preserving the conditions that allow consciousness to contemplate its own cosmic origins. The magnetic field reminds us that Earth is not a static ball of rock, but a dynamic, living system where processes deep in the interior interact with forces from space to create the stable environment we call home. It's a phenomenon that seems impossible until you realize it's been happening right beneath you, protecting you for every moment of your entire life. We've reached one of the most dramatic and emotionally powerful chapters in Earth's story. the snowball Earth epochs, when our entire planet became encased in ice from pole to pole, creating a world so alien and hostile that it nearly ended the story of life before it could truly begin. Yet from this cosmic winter emerged innovations that would change the trajectory of evolution forever. Picture yourself standing on Earth about 700 million years ago, during what geologists call the Cryogenian period. But you wouldn't recognize this world as the same planet you call home. Stretch your vision across the entire globe, from the highest mountains to the deepest ocean basins, and everything you see is white. Ice covers the continents in sheets miles thick. The oceans have frozen solid from surface to seafloor. Even at the equator, where tropical rainforests should flourish, there's nothing but endless fields of ice and snow stretching to every horizon. This is Snowball Earth, and it represents the closest our planet has ever come to becoming permanently uninhabitable. The average global temperature has plummeted to -50 degrees Fahrenheit. The ice is so thick that it reflects almost all incoming sunlight back into space, creating a feedback loop that keeps the planet locked in perpetual winter. If you could observe Earth from space during this time, it would appear as a brilliant white marble, more reflective than Jupiter's ice-covered moons. But here's the emotionally profound part of this story. Beneath all this ice, in tiny pockets of liquid water warmed by geothermal vents or by the slight heat generated by radioactive decay, life refuses to give up. Microscopic organisms cluster around hydrothermal springs on the ocean floor, in cracks within the ice where volcanic heat creates temporary refuges, in underground lakes fed by the planet's internal warmth. Life has been reduced to its most essential forms, clinging to existence in Earth's most protected places. The cause of this global glaciation connects to processes we've been following throughout our journey. As the continents drift across Earth's surface, driven by plate tectonics, they sometimes cluster near the equator. When this happens, the tropical regions experience increased rainfall and chemical weathering of rock. This weathering process removes carbon dioxide from the atmosphere, and since carbon dioxide is a greenhouse gas, its removal causes global temperatures to drop. Normally, this cooling would be balanced by volcanic outgassing, which returns carbon dioxide to the atmosphere. But during a snowball Earth event, the cooling becomes so extreme that most volcanic activity becomes buried under ice, breaking the normal carbon cycle. The planet falls into a frozen state that could, in principle, last forever. Yet Earth doesn't remain frozen forever, and the reason connects to the same volcanic forces that helped create our planet in the first place. Deep beneath the ice, Earth's interior continues its patient work. Magma continues to rise from the mantle, and volcanoes continue to erupt, even though their flames are immediately quenched by the ice above. But this creates a crucial imbalance. Carbon dioxide continues to enter the atmosphere through volcanism, but with most of the planet frozen, there's very little weathering to remove it. Over millions of years, carbon dioxide gradually accumulates in the atmosphere. And since carbon dioxide is invisible to visible light, but absorbs infrared radiation, it begins to trap heat from the sun more efficiently than the ice can reflect it away. This is the same greenhouse effect that warms Earth today, but during Snowball Earth, it becomes a rescue mechanism. Visualize the moment when this cosmic thermostat finally tips the balance. After tens of millions of years of ice age, the accumulated carbon dioxide reaches a critical threshold. The greenhouse effect becomes strong enough to begin melting the ice, starting at the equator, where sunlight is most direct. As dark ocean water becomes exposed, it absorbs sunlight instead of reflecting it, accelerating the melting process. The transition from Snowball Earth to ice-free conditions happens remarkably quickly in geological terms, taking only a few thousand years. It's like a planetary spring awakening after the longest winter imaginable. Ice sheets that took millions of years to accumulate disappear in what amounts to a cosmic instant. Sea levels rise hundreds of feet as continental ice sheets collapse into the warming oceans. But here's the most beautiful part of this story. When life emerges from its icy refuges, it doesn't just return to its previous forms. The extreme stress of survival in a frozen world has driven evolutionary innovation at an unprecedented pace. The organisms that survived the snowball Earth events have developed new biochemical pathways, new cellular structures, new ways of capturing and using energy. Most remarkably, it's shortly after the last snowball Earth event that the first complex, multicellular life forms appear in the fossil record. Scientists believe that the environmental stress of global glaciation may have provided the evolutionary pressure needed for single-celled organisms to begin cooperating in ways that led to the first animals. As you contemplate this chapter of Earth's story, feel the resilience that's encoded in every cell of your body. The ancestors of every living thing on Earth today survived at least 2, and possibly more, snowball Earth events. The mitochondria that power your cells, the genes that encode your proteins, the basic biochemical pathways that keep you alive. All of these have been tested by the most extreme environmental conditions our planet has ever experienced. This is the emotional peak of Earth's formation story, the recognition that life's greatest innovations often emerge from its greatest challenges. The frozen epochs that seemed like endings were actually beginnings, pressure chambers that forged complexity from simplicity, cooperation from competition, and ultimately, consciousness from chemistry. The snowball Earth epochs remind us that our planet's history is not a smooth progression toward habitability, but a series of dramatic experiments in survival and innovation. Each crisis that life has survived has made it stronger, more adaptable, more capable of thriving in diverse environments. And each time Earth has pulled itself back from the brink of becoming a lifeless ice ball, it has emerged more complex and more beautiful than before. As we settle into the gentler rhythms of this cosmic story, we arrive at one of the most remarkable chapters in the history of life. The Cambrian explosion, a period when Earth transformed from a world of simple microscopic organisms into an ocean paradise filled with the first complex animals. This is where our story begins to shift from the violent cosmic forces of planetary formation to the more subtle and intricate processes of biological innovation.